Hello, Michael Dennon here with the physics of X, where X is everything except politics, and we're in our X equals change series. It's the second episode in that series. We started off with Scrooge and the Grinch. If you're liking this, of course, like the video, subscribe, and ring that bell so you always get notified. What are we going to talk about next? Well, of course, everyone's favorite subject, calculus, invented by Newton and Leibniz to help us describe change. Why do we need a way to describe change? Well, just think about the most common everyday change in physics, which is moving somewhere. You're walking to your friend's house, you're changing your position, you're moving from one house to another, it's changing in time, all sorts of interesting things are happening, and now we have to figure out how to measure it. Well, if we step back in time a bit, people pondered this, philosophers in particular, posed an interesting question. To get somewhere, you first have to get halfway there. Well, now you still have to get halfway from where you are to your final destination, and this goes on an infinite amount of time. So the question is, how do you get somewhere if you always have to first get halfway there? Well, this is one of the problems that calculus solved. It allowed us to deal with what we call these infinitesimals, these really small divisions of space and time, and figure out how to describe it mathematically. And this is, people get all worked up about calculus. They think it's extra hard. And there are some parts of it that are hard. But what I hope to kind of give you the sense of today is it is, at the end of the day, just telling you how a certain quantity is changing as you change another one. So, as I said, big one is motion. How is your position changing as time is changing? But you can actually look at all sorts of other changes. You could ask, how does the volume of something change as you change the surface area of it? You could ask, how does your mass change as you make yourself bigger or smaller and, say, keep the density constant? There's lots of things we're interested in changing, and when we do that, we use calculus to describe that change. It's a descriptive feature that's really important in a lot of the physics we do, but a lot of the everyday things. Because I think a very personal thing for most people is, how does your money change? We're all interested in when we put our money in the bank, or when we invest it in the stock market, or when we buy real estate, we like to know how the value changes in time. And that change, I think, is something we tend to develop a good intuition for if we pay attention. And right there, you're developing an intuition for calculus. So the first thing we need to know about the physics of change is how to describe it. And the big tool for describing change is calculus. Now, at a simple level, what's nice is you can approximate calculus by just taking small differences. You can subtract the position you moved by the time you took to move it and estimate calculus. What calculus allows you to do, as I said, going back to this moving halfway, is to deal with very small pieces very accurately. Now, what we'd really like to know is what causes these changes, and that'll be the subject of the next video. So this has been the physics of X, where X is change, and in particular calculus. See you next time. This has been the physics of X, where X is everything but politics. Make sure you like, subscribe, and ring that bell so you get notifications of every episode coming weekly straight to you.